This video is going to cover the section in your trigonometry flipbook called Right Triangle Similarity, and this is in section 2, the top flap of your book. And here's your essential question: how does the altitude to the hypotenuse of a right triangle create similar triangles? Let's go back and I'll give you a chance to do this. Essential question: how does the altitude to the hypotenuse of a right triangle create similar triangles? And there's a lot of words here. Some of these words you've used before, like you know what a hypotenuse is, you know what a right triangle is, you know what a similar triangle is. The new word here is altitude. And an altitude is a line. If you see right here, let's just write this down. The altitude of this triangle is segment CD, segment CD. The altitude is segment CD. And an altitude is a segment that's drawn from one of the sides of the right triangle up to the opposite vertex. So in this case, you see a segment starting down here at the bottom of this triangle goes up and it touches the vertex CD. And to be an altitude, where this line segment touches side AB of this triangle ABC has to be perpendicular. So that means it has to be a right angle. So CD is the altitude of this bigger right triangle ABC. And notice here, class, we know this is a right angle. We're given that. And we also know this is a right angle because CD is defined as an altitude. So what's interesting about this diagram is if you take a right triangle and you draw an altitude from the hypotenuse to the opposite vertex, it does something pretty cool. It creates three similar triangles with that one segment CD. And let's take a look at that. I'll just make a note here so you can write this to yourself. All three, let's use our abbreviation, triangles are similar. Let's prove that now. Show you that this will always work. So let's go ahead and label these three triangles. You look at this, class, this triangle, we're going to call this the large triangle. I'll put an L there and I'll put a circle around it. This is the large triangle. This is the main diagram right here. So look at your vertices. It's vertex A and there's vertex B over here. Let's draw that a little bit more neat. So you can see this is B. And then this is vertex C, and we know this is a right angle. And let's go ahead and do the next triangle. Take a look at this one right here. This little triangle right here, that's our medium triangle. And that, take a look at this triangle. C is at the top. A is still over at the bottom left, but now D is our third vertex for the medium triangle. And then our small triangle right here, take a look at that, it's right here. C is still on top. D is now over here in the bottom right, and B is over here at the bottom left. And we know, class, this is a right angle because it's made with the altitude, and this is a right angle because it's made with the altitude. So the question is, how do we show that these three triangles are similar? And we can do that by using the angle-angle theorem, or the AA similarity theorem. And here's how easy that is. Take a look. We know that this angle right here, angle A on the big triangle or large triangle, is congruent to angle A on the medium triangle because they're the same angle. Now if we compare the medium and the small, take a look at this. We know that angle A right here, sorry, let's do angle B first. So angle B is on the big triangle. Let's draw that with, let's mark that with 2 arcs. Well, that's clearly congruent to angle B on the small triangle because it's the same angle. So now we've got these triangles, and look at, class, these two triangles, the large and the medium, they are guaranteed to be similar because they have angle A is congruent and angle C and angle D are congruent. They both have two congruent angles. That means they are similar, and that also means, class, that we know this angle right here has to be congruent to angle B, because once you determine that these two angles are similar, you know that corresponding angles have to be congruent. So now we know that angle C is congruent to angle B if you look at angle C in the medium triangle. And then look at the medium and the small. Well, angle C clearly is now marked as congruent to angle B, and if they both have a right angle, now they have two angles that are congruent. Therefore, we know that angle A and this angle C have to also be congruent. So now you can see we've got three triangles. All their corresponding angles are congruent. And so we know already that they are similar by the AA theorem. Let's write down our similarity statement. So based on this information, we know that triangle ABC must be congruent to triangle. Let's match up the angles. A goes to A, B goes to C, and C, which is the right angle, goes to D. There's our first similarity statement. Next, let's take our medium triangle. Actually, let's go with our large and our small. Angle ABC, let's show that it must be, not congruent, must be similar to, if I said congruent before on triangles, I'm mistaken. They're similar because they have corresponding congruent angles. So a triangle ABC is also similar to the smaller triangle. Let's match them up. Angle A, our first position, matches up with angle C. Angle B, right here, matches up with angle B. And angle C, our right angle, matches up with angle D. So triangle ABC is similar to triangle CBD. And then let's do the last one here. Let's take our medium triangle, triangle ACD. It doesn't matter what order we pick as long as we match them up with their corresponding vertices. Medium and small. A goes to C because it has a single arc. C goes to B, it has a double arc. And D is the right angle that goes to D. So there you go. We have proven now by the angle-angle similarity theorem that all three of these triangles are similar. And let's write down here angle-angle similarity. Angle-angle similarity. You're going to find in the next video, now that we know that these triangles are similar, we can go ahead and use all the things we learned about trigonometry to find any missing side or any missing angle of these three triangles as long as we have or know a minimum amount of information. So I'll stop this video. We'll go ahead and go to the next section, part B, and we'll fill out the right side of this page.